Hello and welcome to the December 2024 update for Blue Sky Aces, a low-poly World War I flight simulator currently under development. Looking back, it's been a busy year since Steam Next Fest in February, when the game got a lot more attention. Since then, the project has gone from a casual part-time hobby to what sometimes feels like another full-time job. It's been interesting to reflect on this while having some time off over the Christmas break. The last couple of months have been particularly trying, as I've been working furiously to create a new simulation flight model, which will provide a more realistic experience for players who enjoy that side of flight sim. The first phase of this work is now almost complete, with just some testing and tweaking of individual aircraft performance remaining. Unfortunately, this has taken way longer than I'd hoped it would, but I should have a demo update out with this change in January, once I've got the green light from the beta testers. One of the cool features added recently was the rendering of damage to aircraft. This is a feature that's been on my radar for quite some time, but I wasn't quite sure how best to implement it. One of the typical approaches that I've used in games in the past is to place a small textured quad at the point of impact. This is really easy to do and is just as easy to optimize. However, it tends to work best on large flat surfaces like walls, so I had plenty of doubts as to whether it would work on detailed surfaces of the aircraft. In theory, I would need to shrink wrap the quad to the surface as well as clipping any overhanging parts. This all felt like a lot of complicated math that would need to run for every single bullet strike, and the bullet holes would only show on one side of the aircraft. Another approach was to use Unity's built-in decal projectors to project holes onto the aircraft surface. However, this felt like a really heavyweight solution that didn't promise to scale well. I even considered a damaged texture that would update at runtime and then blend with the base texture. However, this too promised to be very challenging to implement. In the end, I found this tutorial by Ronja while trying to find a better way to project decals onto terrain at work, which I realised could also be used to project bullet damage onto the aircraft. Best of all, it promised to be fairly lightweight, easy to optimise, and it would handle conforming to other complex shapes without any additional work. Plus, it even handled the holes showing on both sides. It works by using a clever shader that turns a simple 1 meter square cube into a tiny projector that perfectly wraps the texture to any object within the cube's bounds, using data within the depth texture. Each cube is scaled to make them look long and narrow to mark the path that the bullet took when it went through the aircraft. Cubes that extend beyond the sides of the aircraft will automatically project the holes onto both sides, making it look like the bullet has gone straight through. This solution automatically handles the case where holes are on the edge, as it won't render unless there's an object to render onto. To further improve the look, I've gone with a decal texture that's actually a cluster of holes to make the damage look more obvious, as a single hole was quite difficult to see at normal combat distances, and larger holes looked weird at close range. For now, this effect has been applied to aircraft, balloons and vehicles. However, in the future I'd like to add it to buildings, trains and anything else that makes sense to. While the solution is good, there are a couple of items that need some more work in the future. The first is that the holes can project onto the terrain surface after a crash, which I believe I can fix with the use of the stencil buffer. The other is that the number of jaw calls sent to the GPU is a little higher than I would like, so I'd like to investigate options to batch render the decals to reduce this. The other really exciting feature added is head tracking, specifically support for Track IR. However, other brands of head tracking should work as well, so long as they support the Track IR protocol. Head tracking, for those who don't know, is a way to get near VR-like immersion, but without the expensive headsets. The exact technique varies a bit, but generally speaking, systems consist of a camera that tracks the player's head position and orientation, and then passes this information onto the game. The values passed onto the game get scaled, allowing you to look behind you in the game while only turning your head part of the way. The purpose-built solutions tend to use cameras that detect infrared emissions from special clips worn by the player, but there are free alternatives that work with nothing more than a standard web camera. I did my development and testing with the latter, and I can honestly say that it provides a very good, cheap solution that's worth giving a try. You can see in the video that the system is using AI to track points in my face, which it then uses to identify my head position and orientation relative to the neutral position. I'll put a link in the description to a tutorial that I've used to get it set up, which I'd highly recommend giving a try if you haven't used this technology before. The same solution will work with many of the other flight simulator games out there on the market too. The goal for next month is to get the demo build updated, as this last update feels like it's been a long time coming. Once the update is out, my plan is to switch to looking at ways of better generating maps and missions more efficiently, as the current approach is very manual and it greatly restricts the size of the maps and how many I can make. The first part of this work is to create a map editor, which will hopefully automate many of the slow and tedious elements like placing terrain tiles, towns, forests, trenches and roads. I'm sure that there's going to be a lot of challenges with this new approach, so initially I want to do it in a way that streamlines the existing process rather than replaces it. My reasoning here is that I could stop at any point if I feel like it's all looking too hard and still have some benefits. If you'd like to find out how I got on with this, then don't forget to hit that subscribe button so you won't miss out my next update. And give me a thumbs up if you found this interesting. If you'd like to give the game a try, then check out the link in the description to the game's Steam page where you can play the demo for free. And don't forget to wishlist it so you'll be notified when the game is released. If you got this far, then thanks for listening, and I'll see you again next time.